If you look up at the very heart of the winter sky, you'll see the brilliant stars of Orion, Sirius, and Procyon. But right in the middle of them, there's this huge expanse that for centuries was just, well, a blank spot on the old star maps. This is Monoceros, the unicorn. It looks like an empty void, but hidden in that darkness are cosmic events that have completely changed how we understand the universe. So let's begin our examination.
Here's our plan for this explainer. First, we're going to tackle its strange nature as this invisible giant. Then we'll get into its history and exactly where to find it. After that, we dive into the incredible astrophysical drama playing out inside its borders. And finally, we'll touch on the mythology and give you a practical guide to see these hidden wonders for yourself.
So we start with a central paradox. Monoceros is a really big constellation. It covers more than 480 square degrees of the sky. But if you just use your eyes, you see nothing. It's an abyss. And that right there sets the stage for our entire investigation.
And this is the fundamental question we're going to try and answer. You see, the emptiness of Monoceros isn't because there's nothing there. It's more like a veil. Our job is to use the tools of astrophysics to pull back that curtain and see the absolutely titanic processes of stellar catastrophe and creation that are happening in the dark.
Okay, before we can explore what's in Monoceros, we have to figure out where it is and how it got its name. So let's take a look at how this region went from being just a bunch of unformed stars to a recognized constellation on our celestial charts.
To find Monoceros, you first need to find the winter triangle. It's easy. Just picture a line from the red shoulder of Orion, that's Betelgeuse, down to Sirius in Canis Major, the brightest star in the sky, and then over to Procyon in Canis Minor. Monoceros is the dark, seemingly empty void sitting right in the middle of that giant glowing triangle.
Now, what's fascinating here is that even though none of its stars are all that bright, they are scientifically very important. Alpha Monocerotis is a pretty close orange giant, but the real jewel of the constellation is Beta Monocerotis. When William Herschel saw it back in 1781, he was just astonished, describing it as a view of 3 blue-white diamonds frozen in an eternal dance. It's this beautiful, gravitationally bound triple star system.
The story of how this region even got on our star charts is pretty cool. To the ancient Greeks, these were just informous, unformed stars, scattered between the big-name constellations. It wasn't until 1612 that the Dutch theologian Petrus Plancius actually drew a unicorn here. And he was motivated not just by science, but by the unicorn's symbolism in biblical texts. It was then formalized by Jacob Bartsch and eventually given its official Latin name, Monoceros, by Johannes Hevelius.
All right. Now we move away from the maps and into the world of high-energy astrophysics. And this is where Monoceros stops being an empty space and becomes a stage for some of the most violent and also creative processes in the entire universe.
So to understand what's happening here, we first need to define a key term, merge burst. Back in 2002, a star called V838 Monocerotis had this really unique outburst. Now, it wasn't a classic nova, where a star blows its outer layers off. V838 didn't explode, it just swelled up. The leading theory for this is a merge burst, a rare catastrophic event where 2 stars actually collide and become one.
Let's try to visualize this. Imagine a smaller star spiraling closer and closer to its larger partner, until it finally plunges into its atmosphere. This crash triggers a colossal release of energy. The star doesn't blow itself apart, but its outer layers inflate to an unbelievable size. I mean, if this happened in our solar system, the star's new surface would have stretched out past the orbit of Jupiter. Afterwards, the surface cools, and what was a hot blue star becomes this vast glowing red supergiant.
And this leads to one of the most spectacular things the Hubble Space Telescope has ever captured. As the pulse of light from that merge burst traveled outwards, it ran into shells of dust that the star had ejected long ago. The light lit up these shells one by one, creating this stunning light echo. What's key to understand is that you're not seeing an expanding shell of gas, you're seeing a wave of light revealing ancient invisible structures. It's like a cosmic ultrasound scanning the void.
So, we go from the drama of a single star to a place where stars are born. The Rosette Nebula is this colossal cloud of gas and dust with the total mass of 10,000 of our suns. Right at its heart, there's a cluster of young, massive stars. Their fierce stellar winds and intense radiation have blasted a huge hole in the center of the cloud, carving the gas into the beautiful shape that we see as a cosmic rose.
Monoceros is also home to one of the absolute strangest objects in the sky, the red rectangle. It's what's known as a protoplanetary nebula, what's left over from a dying star. Its bizarre X-like shape still isn't fully understood, but what's truly profound is what it's made of. We've found complex organic molecules here, things like anthracene and pyrene. This proves that the fundamental building blocks of life can actually form in the harsh environment around a dying star.
And finally, we come to cosmic annihilation. The A06200 system has a black hole about 6.6 times the mass of our Sun, and it's locked in this parasitic dance with an orange star. The black hole's immense gravity is literally pulling a ribbon of plasma off of its companion. This material doesn't fall straight in. Instead, it forms a superheated accretion disk, a swirling vortex of matter heated to millions of degrees, glowing brightly in X-rays right before it crosses the event horizon and disappears from our universe forever.
So, beyond all the incredible physics, there's also symbolism. Now, Monoceros doesn't have any ancient myths of its own, but its position in the sky creates this powerful modern story, a philosophical drama playing out across the winter heavens.
Think about the arrangement up there. You have the great hunter, Orion, striding across the sky. He's flanked by his two hunting dogs, Canis Major and Canis Minor. And what's directly in their path? What are they chasing? It's Monoceros, the unicorn. The prize is huge, but it stays invisible, an elusive ideal, the ultimate truth, that the hunter can chase for all eternity but can never actually catch with his own eye.
All right, let's wrap this up by turning all this theory into practice. I'll be honest, observing Monoceros is a real challenge, but it's incredibly rewarding. So here's a quick guide to help you get started.
The best time to look is February, when the constellation is highest in the sky. Find that dark patch we talked about, right between Procyon and Sirius. With a simple pair of binoculars, you can actually see some star clusters, like the Christmas tree cluster. But to see the faint glow of the Rosette Nebula, you're going to need a telescope with at least a 150mm aperture. And this is crucial, a really dark sky, far away from any city lights.
Ultimately, Monoceros teaches us a really fundamental lesson about the cosmos. The universe is not always what it seems. Behind a veil of what looks like total emptiness can lie the most profound and dynamic processes you can imagine. It's a perfect symbol of everything that's hidden out there, just waiting for the right tools and the right questions to bring it into the light.
And so, we'll end with a question for you to take out into the night. The next time you look up and see a dark patch between the stars, don't just see it as empty. Ask yourself, what colossal mergers, what stellar nurseries, what invisible singularities might be hiding in there, just waiting for their moment to be discovered?